Hello, my dear student. Welcome to Vakanesa Trust YouTube channel. Those who have not subscribed so far, do subscribe our channel to get a lot of information and mathematical solutions. Today, I am going to give you a presentation on Heron's formula. What is Heron's formula? What is its application? And why do we need Heron's formula? All those things will be taking you through a couple of PowerPoint slides after this introduction. Okay, again, do listen carefully, understand the application. That is more important. Understanding the application, why we have to use the Heron's formula, we should understand that. Heron's formula basically is used when we have only can measure the length of the triangle, and we have the information about the length only, not any other information. For example, a large triangular park, you can measure the length along the side like this, but you cannot have measure the angle, you cannot measure the vertical height, all those things. During such time, if you have to calculate the area, there comes Mr. Heron. Okay. More about this I'll be presenting in the PowerPoint. Do watch, like the YouTube channel, share and subscribe. Thank you. Welcome. Hello dear students. Let's get on to the topic, Heron's formula. This is Vardarajan from Vakanesa Trust. So, are you ready? Okay, we'll today discuss about the Heron's formula, certain prerequisites, what we have learned in the earlier classes. Let us brush up our memory and then proceed to understanding Heron's formula. Okay, this is for class 9 under chapter 8. So, let's begin to understand what's Heron's formula, who invented Heron's formula, and why Heron's formula is required, where does it find its application, and also we solve a couple of problems related to Heron's, using Heron's formula. Okay. Now, Heron of Alexandria is a Greek mathematician and also a mechanic. He invented Heron's formula and also lot of other machines including steam turbine. So before we get into Heron's formula, let us understand certain prerequisites. Number one, this is nothing but we are refreshing our memory of what all we studied in our earlier classes or previous classes. Perimeter and area. This is very important to understand Heron's formula. Square and square roots. Triangles and types of triangles. All these things we have studied, but again we are only trying to recollect, refresh our memory so that we get on to Heron's formula and understand without difficulty. Area of a triangle. Area of a triangle when its base and height is given. This all you have learnt already, but anyway we are refreshing it. So area of a triangle is nothing but half into base into height. Next important is Pythagoras property and Pythagoras triplet. Perimeter. What is perimeter? Students, are you ready? Can anyone tell me what is perimeter? Who? Oh wow. Good lot of answers coming up. Okay, let me show you what is perimeter with a practical example. You all have gone to temples, and in the temple you go around the temple in a clockwise direction, maybe once or 3 times depending on what all your parents would have taught you. Okay, this is a sort of prayer. So what do? We go along the perimeter. This is what is called perimeter. All along the boundary is perimeter. This is a practical example. Now let's take a look at the hockey stadium in our next slide. Why did I choose hockey stadium? Hockey is our national game. Yes. So what do you see here? You see a rectangular patch, green boundary and a border line. So let's get on to area. Dear students, let us refresh our mind on area calculation. What is area? Oh, a lot of people are ready to answer. Okay. Area is the total amount of surface enclosed by a closed figure. Very good. To understand, let's look at the hockey stadium again. Okay. What do you see? The green surface you see is the playing area. I am repeating, it is the area. Okay, that is the playing area. The total length along the border of the green surface is the perimeter. That is the boundary line is the perimeter. Why is area important? Let's take a look at this park. Why we need area? Let us understand practically, okay, with an example. Suppose we are asked to lay tiles along the walkway. You are seeing the walkway now along the greenery? Yes, that is the walkway. If you have to lay the tiles, you should know how many tiles are required to procure. How do you find it? For example, tiles are made into 10 inch by 10 inch. That is the standard. Maybe someplace it is even made into a different measurement. Let us take it as 10 by 10. 10 inch by 10 inch. That is 100 square inch. That is the area of the tiles. Now we need to find out the area of the footpath. That is walkway. Once we find out the area of walkway, then we can divide that area divided by the tile area, which gives number of tiles required, so that we can procure and lay the tiles. The next example, simple example. Suppose you need to paint your house whose built up area say 1500 square feet. Okay, how do you find? Let us assume you take the wall, measure the wall both length as well as breadth, and multiply, you get the area. Once you get the area, you can find out how much paint is required depending on its coverage area. The coverage area normally is specified by the paint manufacturer, so that we can buy as many liters as required to paint the wall. So to find the area, let us take certain shapes and understand what is area. For example, area of a square. Area of a square is, you all know, you have studied, is side into side. Because in an area, in a square, both the sides are equal. Is it not? Yes. That is why it is side by side. So let us take an example of rectangle. In a rectangle, the two opposite sides are equal. One is length, other one is breadth. Both lengths are equal, breadths are equal. So here what we do? We multiply length by breadth, L into B. Okay. Now let's go to triangle. So what's a triangle? Triangle. Yes, lot of many answers coming up. Yes, wonderful. Okay. Triangle is a plain closed figure with three sides and three angles. Very good. Triangle can be classified according to its sides. When we say based on sides, it is equilateral triangle, isosceles triangle, and scalene triangle. And based on angles, it is acute angle triangle, right angle triangle, and obtuse angle triangle. Let's tabulate the angles. Okay, so that the picture will get registered in our memory for a longer time than any other things. You always correlate with some pictures, so to remember something that will remain for a long. So I'm showing you the pictorial view of various types of triangles. Number one, equilateral triangle. Number two, isosceles triangle. And there comes Heron triangle. Then let's go to see triangle based on angles. Okay, the first one comes up, acute angle triangle, then comes the obtuse angle triangle, and comes the right angle triangle. Okay, so students, we have discussed about certain shapes. Now we shall discuss about the area of a triangle. Area of a triangle when its base and height is given. What is the area of a triangle? Area is equal to half base into altitude. That is half into base into height. Okay. Question. Let's solve a simple question. A triangle with base BC as 8 centimeter and height AO as 12 centimeter. What is the area? Area is equal to half into base into height, that is half multiplied by 8 multiplied by 12, which is equal to 4 into 12, which is 48 centimeter square or square centimeter. Area of an equilateral triangle whose sides are, say, a centimeter. The equation for this is square root of 3 divided by 4 into a square. Let's solve a cell equation wherein a question where the sides are given as 16 centimeter. Okay, look at the figure. The triangle ABC, the sides are 16 centimeter each. The solution for this is area of this triangle is equal to square root of 3 divided by 4 multiplied by a square, and if you substitute a by 16 it comes to square root of 3 by 4 into 16 square, which is equal to square root of 3 divided by 4 into 16, which is nothing but square root of 3 into 64, which again leads to 1.73 into 64 is equal to 110.72 square centimeter or centimeter square approximately. I am using approximately because the decimals will continue. Okay, now the today's topic. So far we discussed about the prerequisites only to understand the Heron's formula, and now we are heading to learn what is Heron's formula. Heron's formula, also known as Hero's formula. As I told you in the beginning, Heron is an Egyptian mathematician and he was also a mechanic. He has developed a lot of machines and also was instrumental in bringing out the steam turbine. Okay. Heron invented the equation for a triangle to find the area of a triangle whose sides are only known and no other parameter. Okay, no other information. So what he did, he calculated the length of each side and deriving at the semi-parameter. What is parameter? We know it is a plus b. Semi-parameter is a plus b plus c divided by 2. That is half of perimeter is semi-perimeter. His formula is to find the area is equal to square root of semi-perimeter, that is S, multiplied by S minus A multiplied by S minus B multiplied by S minus C, where A, B, C are the three sides of the triangle. Okay. So shall I repeat? Heron's formula is to find the area of a triangle whose sides are given. So the formula is semi-perimeter S, which is equal to half of perimeter, and area, to find the area, it is square root of semi-perimeter S multiplied by S minus A multiplied by S minus B multiplied by S minus C. Okay, with this let us try to solve few questions to understand the application. Okay, now take a look at the triangle PQR where the sides are 4 centimeter, 13 centimeter and 15 centimeter. So what is semi-perimeter of this PQR? S is equal to 4 plus 13 plus 15 divided by 2, which is equal to 16 centimeter. Okay, semi-perimeter is 16 centimeter. By Heron's formula, let us now find out the area of this triangle. So with the Heron's formula, area is equal to square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. Here we substitute A, B, C by the respective dimensions of 4, 13 and 15. With this, the equation tends to square root of 16 multiplied by 12 multiplied by 3 and multiplied by 1. Therefore, the square root of 4 by 4 by 4 into 3 into 3 into 1 is equal to square root of 576, which is equal to 24 square centimeter or centimeter square. So the area of this triangle is 24 centimeter square. Is it easy? Yes. With the sides, given sides, we didn't have any angle, we didn't have any other information apart from the sides of the triangle, through which we could calculate the area using Heron's formula. Yes. Let's work out another example. In this example, we see a traffic sign board near a school. You would have seen this board as you just get into the road of your school. Just before the school, you see a board, school ahead. Why this is used? So that people will drive carefully and slowly. Why that is required? To take care of the children around the school. Okay. This board, the dimensions is given as 60 centimeter all sides. It is an equilateral triangle. Equilateral triangle, we can find the area by normal method, but in this case we are trying to find the area using Heron's formula. So what is we have to do? First we have to find the perimeter, that is AB plus BC plus CA, that is equal to 60 plus 60 plus 60, 180 centimeter. What is semi-perimeter? Semi-perimeter is A plus B plus C divided by 2, that is 180 divided by 2 is equal to 90 centimeter. Its semi-perimeter is 90 centimeter. So now using the Heron formula, we'll calculate the area of this particular triangle. A is equal to, as you all know, square root of S into S minus A multiplied by S minus B and multiplied by S minus C. So when you substitute A, B, C with 60 centimeter each, the equation brought down to square root of 3 into 8 lakh 10,000. That means if you remove the square root, you get 900 multiplied by square root of 3 square centimeter. This further you can simplify by putting the value of root 3 as 1.73 and calculate the required area. Okay, with this, hope you understand the Heron formula, its application, and whenever it is necessary, wherever you find this is useful, you have to use this formula to calculate the area. Okay, with that, let me conclude this lesson of Heron's formula for today. We'll come up with a few more such mathematical presentation later. And before that, to get into all that information, I request you to like this video and share this YouTube channel, subscribe to our YouTube channel, Vakarnesa Water, Share with your friends also, ask them to subscribe so that the information is available to lot more students, not just you. You can share, you can ask them to subscribe, you can also ask them to view this video, understand, like, and in case of any doubt, you can always contact Okarnesa Trust. My name is Vardarajan. Will be there to answer your question. Thank you. Bye bye. All the best. Take care.